Hello everybody and welcome back. We're looking at question number 2 on the 2008 Manitoba Math Contest. Question 2 broken down into two parts. Find the real numbers a and b if 2 and 3 are roots of x cubed plus ax squared plus bx plus 6 equals 0. So it's a cubic and we're told two of the roots. Now does that mean one of the roots is duplicated? I don't know. But what can we do to find A and B? Alright, well, copy down the equation. So we got x cubed plus ax squared plus bx plus 6 is equal to 0. Well, we can plug in 2. We know that makes this equation true. So 8 plus 4a plus 2b plus 6 equals 0. But if we plug in 3, we know it also satisfies everything. We'll get two equations in two unknowns. And this should be enough to solve for A and B. Okay. What can we do here? Well, we can bring everything over to one side. So 8 and 6 is 14, so we'll put negative 14 here. 9a and 3b here. 6 and 27 is a negative 33. So suppose I want to cancel out b. I've got 2b here, 3b here. I'm going to multiply this top equation by 3 and this bottom equation by 2. So I will get 12a plus 6b is negative 42. And I will get 18a plus 6b is negative 66. And I will subtract one equation from the other. So we get negative 6a. The 6b's are cancel out. That's why I chose to multiply by 3 and by 2. And then negative 42 minus negative 66. That's just going to be 66 minus 42. 4 and 2. So negative 6a is 24. A is going to be negative 4. And now I can take that and plug it back into, say, this equation. 4 times negative 4 plus 2b is negative 16, or sorry, negative 14, and this is negative 16 plus 2b is negative 14. B is going to be, 2b is going to be 2, so b is just going to be 1. So that finishes off A. If we wanted to, we could double check. 9 times negative 4 is negative 36, plus 3 times 1 is negative 33. So yeah, it all worked out. Alright, so we'll flip the page. We still have another half of this question to do. 2b. In this problem, a and b are the 2 points at which the graph of the equation x squared plus y squared equals 8. So already I stop right there and say, hey, this is an equation of a circle whose radius is square root of 8. So this helps me draw my picture. In fact, I know also that it's centered at the origin, 0, 0 here. So the equation of this meets the graph of the equation y equals x, or absolute value of x. What is the length of segment AB? Well, I can draw this. So it's a circle specifically of radius root 8. And what does the absolute value function look like? It looks like V for victory. So we get 2 points here. One in either half, or in positive x and negative x. We'll always have positive y's. What are we to do? So this over here looks like we'll call it A, and we'll call this one B. So this looks like A, and this looks like B, negative B. Because B over here, it's going to be a negative x value. So, but we need to get a positive y value, so you negative a negative, you get a positive value here. And what exactly did we want? We wanted the length of the segment AB. Okay. I suppose we could solve. Now, a squared plus a squared is equal to 8. So a squared is going to be 4, a is going to be 2. We also have b squared plus negative b squared is equal to 8. B is going to be negative 2 in this case. So our points are, and negative b is going to be 2. So it really just looks like negative 2, 2, 2, 2. And this is a difference of, well, the difference in the x-coordinates is going to be 4. So AB is 4. And you could add a bit more writing, You could also probably just make a symmetry argument, say A and B are the same value, but one of them's positive, one of them's negative. So you just do it from this equation up here. Substituting x squared plus absolute value of x squared is 8. Well, you're just going to get 2 copies of x squared here. So that'd be fine as well. You don't need to, but that wraps things up quite nicely for question number 2. And I will see you guys for question number 3 in the next video.